Good afternoon and welcome to the Sunoikisis Digital Classics Fall 2016 semester. This is the semester based on digital history and archaeology. And this is week 7. This session on ontologies and data modeling will be presented by Arianna Ciula from Roehampton University and Charlotte Tupman from the University of Exeter. And we're extremely pleased to have them with us, and we look forward to this session. I'll hand over first, I think, to Arianna.
Yes, thanks, Gabi. Hello, everybody. I will try first to very quickly share my screen with you so you can see what I see, and moved into my slides. Here we are. So does everybody see the slides? I hope so.
Yep.
So this class, as Gabi introduced, will focusing on ontologies and data modeling, and will be presented first by myself in the first part, and then by Charlotte Tupman. I am based at the University of Roehampton, and Charlotte is based at the University of Exeter. Very briefly summarizing the topics of the class, we will first introduce briefly what an ontology is, specifically as a type of data model. I will then go through some of the components of what an ontological analysis is, whether one has to build an ontology from scratch or use existing models. Then we will go through a little bit the kind of formalisms, the way an ontology can be expressed. And then last but not least, of course, we will try to contextualize some of these concepts within specific context and uses in digital classics, archaeology, and history. We will try to do this while we talked across the various topics, and then especially at the end. So I'll start with the kind of classical understanding of the pyramid of data, information, and knowledge, just to introduce what data models are. So if we think of data as bits and bytes that constitute various kinds of digital objects, we can assume that potentially they are quite unstructured. While when we talk about information, we contextualize those data within more specific categories and structure, we could say. And then on top of the pyramid, we add knowledge, intending with knowledge the kind of interpretation and human activities around this information that allow us to work with this information and make sense of it. So it's very important, I think, to keep, even if this basic distinction, even if they're basic, to understand what at the basic level a data model is. So a data model is a kind of formalized description of how to organize data specifically within an information system, with all sorts of purposes in mind, including consistency of data, how to maintain them, how to store them, and so on. So we could say that ontologies are a specific kind of data models, and they're specific kind of data models for certain reasons. We can use the classical definition of an ontology given by Gruber in 1993, and then developed further in the literature. If you look at the class outline, you will see various readings you can deepen this understanding in. So Gruber stated an ontology is an explicit, and I underline explicit, specification of a conceptualization. We will look at that in a minute. And the term is borrowed from philosophy, of course, where an ontology is a systematic account of existence, of reality, we could say. But for artificial intelligence, and we could also say for digital humanities systems, what exists is that which can be represented. And I anticipate here that this is, in fact, a pragmatic view of ontology. So we're not using ontologies to represent how the world is, but in a way, we use it to share a certain understanding of a specific domain of knowledge. So I've already anticipated what this definition means, but let's unpack it a bit further. So first of all, I said an ontology is a conceptualization. What does that mean? It means that it's a kind of abstract, simplified, stylized representation of the world, or of a specific domain indeed. Is explicit in the sense that it's formalized in a consistent way. So the concepts that are shared are expressed in a formal language, which ideally means that they are unambiguous to a certain extent. So they have a clear semantics. And this is why ontologies are then suited indeed to describe and share representations of data. So they're formally expressed contextualizations, we could say. very important element to remember is that, of course, an ontology applies and is a data model for a specific knowledge domain, so usually has a limited scope. And they can vary, of course. We have very different kinds of ontology, from very specialized domains to more general domains. We will look at examples, of course. I already anticipated briefly the distinction between a realist approach versus a pragmatic approach to ontologies, and it's the latter, the one that it's most useful in our domains. And again, in one of the readings, there is this idea of using, in this pragmatic sense, a metaphor around ontology that make us conceive of an ontology as a kind of agreement, negotiation of meaning, a contract, a compromise in a way that will allow us, if I have my own a data model expressed in such a formal way and share with somebody else that model, I might not agree in the total of the semantics, but we might have some common grounds via which we can share data. Very important, of course, an ontology is always mediated, so it has some kind of, it's a kind of information object usually, it's not just a conceptual object out there, it's an artifact with a specific form. So usually a well-designed ontology will consist of at least 3 elements. Some kind of natural language, some kind of description in natural language of the meaning of the concepts expressed in an ontology, and this is very often defined as scope notes, a set of examples, of course, to show how the concepts are expressed and how they can be used. And then, of course, what later on I will define as properties of concepts, so how the concepts are connected to each other, how they can be connected. Obviously, once your ontology is expressed in such a formal way, it's possible to then compare different models, but also to extend a specific model with other models. And that's the whole point of then using ontology, indeed, to reuse the data models themselves, not just the data. Now, before we go into the details of what an ontological analysis entails and how do we create these data models, maybe it's important to say that in general, indeed, we create ontology to gain a deeper understanding of a specific domain and also to analyze the data concerning that domain of interest. Nowadays, compared to, let's say, even just 10 years ago, we have surely better technologies to do this. From triple stores, which I will introduce briefly later on, to graph database technologies and so on. But it's still important to remember that it's not just about technologies, but it's also about the know-how on how to model the data. So this is what this class, in a way, is trying to introduce. And a third element maybe to remember is also that there is a constant tension between the noble purpose of building technologies, which is basically interoperability, making our data resources talk to each other and share information, with the richness and the fact that a lot of our data are complex, and so these meanings are very difficult to reduce. So this tension is always there, and it's in a way part of the power of using ontologies, but also indeed the risk. So, the components of an ontological analysis. First, of course, very important, access to the expert knowledge. Obviously, if we are the expert in a specific domain, we potentially have that implicit knowledge. It's just a matter of making it explicit. But it might be the case that we are contributing to a project where we're working with other experts who, in a way, detain that knowledge. In that case, we might have to elicit that knowledge. So this is a very, of course, important aspect in any kind of analysis. And in the case of ontologies, of course, I should stress that it doesn't deal necessarily with representing a world of reality, but it could be, for instance, an ontology of literary characters or any kind of fictional world. Second element, very important, is that before formalizing in any way the concepts to create an ontology, it's very important to, in a way, extract from that knowledge domain specific examples that we can use then to generalize a wider concept. So the access to specific knowledge is useful exactly for this, to sort of identify the salient properties of a specific domain, which we will then translate in formal terms. So out of the specific example in that specific domain, ideally, we then build a conceptual language. simplifying, of course, but still keeping the richness based on the empirical examples, ideally. Also another step, which obviously these steps are not necessarily all sequential, they happen also in parallel, but in a way it's just an analytical distinction, is documentation, very important again. Whether we use an ontology, a data model that already exists, or whether we are building another one, it's very important to somehow record the information around the concepts we are building and the interconnection across those concepts. So it's very common, for instance, to hear the term of ontology hijacking or abuse when such documentation is either not written well or has been misinterpreted somehow. And then, of course, last step is the implementation, so the storage of the data come information into an information system of some kind, where indeed the data are stored with the model. So what are these concepts? Oh, sorry, and basically to sum up, what an ontological analysis produces is an understanding of a specific domain expressed via basic properties that are specified indeed in a formal language. So what are these concepts then I'm talking about? They usually indeed distinguish between classes and properties. And if any of you is familiar with language of logic, for instance, it would be very easy to get this. Basically, classes are the kind of reference point when we talk about a specific world or discourse. They can also be defined as universals in the sense that they represent entities with their own instances, with their own instantiations in a way. In addition to that, a class is defined usually as a functional concept, that is, by the kind of things you can do with that class, more than simply by a taxonomic definition. So by the kind of interconnection and properties that class has to include specific instances. Another important concept, especially indeed in computer sciences applications, let's say in an implementation phase, is this idea of what is important for the construction of my classes, and more important that my system gain recall or precision. And depending on which one of these two, let's say, poles one tends to, one might want to be very specific in the kind of classes that are defined, or more general. Again, using the kind of philosophy of language concept, we could say the classes are generally, well, should be defined by their intention rather than by their extension. So not so much, a class shouldn't be defined not so much as to what it applies to, but indeed by its own meaning. So the kind of identity criteria, if you like, what is it made of? What are the conditions for its parts and the condition of existence for that class? And we could then indeed engage in what kind of relationship that class can interact with other classes. So the second important concept is indeed properties in this sense. So how a class can then interact with other classes. Indeed, properties are defined at the class level, and they represent indeed this interconnectivity of entities. If we look at this simple example taken from a tutorial for the Protégé OL, which is a tool indeed to build ontologies and to use ontologies, the circle represents the classes. Within the classes we have, if you see those diamonds, which represent the instances. So in the case of the class, the circle person, within it we have Matthew and Gemma as instances. And the arrows, the directed arrows, that link the two diamonds or more than two diamonds are the properties. In this case, Matthew as sibling, Gemma as sibling is a property, or Matthew lives in country England is another property that connects two different classes. It's important that in terms of property, we understand also the concept of domain and range. So if you think indeed as the direct arrow element, so where the properties depart from is the domain, so the class to which it applies, and the range, it's the class to which it's directed to in a way. So if we move into the formalism, what can we say? I had here as well some kind of premises before we go into the details. Usually, obviously, as formalists, we intend indeed the formal structure of an ontology, but it's always important to keep in mind that not everything that is connected to an interpretation of a specific domain of knowledge might be translated into formal structure. So this distinction is important. And this distinction and this shift is important. And in a way connected to this, it might be that we have some kind of ontological commitments within a specific domain of knowledge, which we can indeed express with formal restrictions, but some of these commitments we might not want to express in formal restriction, or it might not be possible to express in formal restriction, or it might not be necessary. So again, these are some distinctions to keep in mind. So as I said before, an ontology definition could then be described into these three elements. So a formal definition, which is what we will go into to look at now. The scope notes, or a narrative, a kind of natural language explanation of the meaning of the concepts and how they interact, and examples. So if we look at the structure, which is indeed what represents a formal definition of an ontology, this is usually expressed, well, in most cases at least, as an object-oriented kind of structure, where you have indeed a class hierarchy and inheritance mechanism of properties. Yes, sorry, I should have moved this. Yes, so you'll have a set of classes and the properties associated to these classes, organized usually in hierarchies. So in this very simple Venn diagram, the class B is therefore a subclass of the class A. And this is a kind of single hierarchy. So we have B within A, but usually in an ontology, you might have multi-hierarchical relationships where, for instance, B could also be a subclass of another superclass. So this element of subclass and superclass is very important to then understand also this context of this concept of inheritance of properties. So if the class A is a specific set of properties, the subclass B will inherit all the properties of A. Now, usually, let's say the way in which an ontology can be expressed could vary. So there are very many formal languages, but first of the logic is definitely the most prominent and for sure the most stringent. Again, I don't know how much you're all familiar with first order logic, but it basically is a kind of propositional logic, which in addition has quantification. So it's a very simple but also powerful way of expressing propositions. But a much more, let's say, used and widespread way of implementing ontologies via the Resource Description Framework, RDF, developed by the W3C consortium, indeed, and widely used in the semantic web. And it's also become quite crucial indeed and essential to the development of linked data, which I will say a little bit more in a minute. Again, we don't have loads of time, but I will try to summarize the main concept of RDF is that basically all resources, in this specific case, of course, all resources available, accessible on the web, should be identified by unique, persistent identifiers, uniform resource identifier, URI. And this, of course, implies that it's very important that we have specific authorities that somehow mint or define these identifiers so that we could locate, point to specific resources. Another important element is that two resources on the web within this framework can be linked via a directed link. And this directed link creates a kind of three-part data structure or triple. The three elements of the triple are the subject, the predicate, and the object. Or each of these, and of course, if you go back to what we were saying before about classes and predicates and properties, within that Venn diagram, the subject and object are nodes, are instances of the universal, and the predicates are properties. And each of these elements can have a type, which indeed is identified then by another URI. In implementation terms, these triples, these RDF triples can be stored in triple stores, which can then be accessed via a specific query language, which is Sparkle. They can form, of course, put together and link together a directed graph, as I said before, of linked data. And this is indeed where the term linked data itself comes from. So the interconnections of these directed graphs. The extension RDFS is then for RDF schema is then how is written itself in RDF, and it allows basically the expression of specific data models for the various nodes and relationships in this framework. On top of this, the W3C also developed another language formally called OWL, Web Ontology language, which I can never pronounce properly, but it allows basically to apply a kind of so-called descriptive logic, a kind of weakened first-order logic on top of RDF, and therefore enable some kind of reasoning of around the properties and classes that have been defined. So in a way, via OWL, we can deduce certain relations that might not be made explicit at first hand. I will give an example later of this. Now, a few words about then ontologies in the humanities. Obviously, as I said before, we use ontology in specific domains, and very importantly, we use it to express a specific meanings. And we intend to make those meanings explicit. And the advantage of this is then we can potentially identify novel ways of integrating resources and reuse them. I mentioned this before, but just to highlight it again, there is of course always a kind of tension between, for instance, the value that we give to specific perspective, or also contradictory perspectives sometimes, or controversial interpretation of specific data in the humanities, and the fact that by adopting sometimes a simple or shallow data models, we might betray that complexity. So it's very important before we adopt already existing ontologies, already existing data models, to make sure that they actually reflect the specific domain we're interested in analyzing. So why then, you will see that later on in the class, we refer a lot to the cultural heritage sector. And why do we do this? Because indeed, that's a domain, or let's say a tradition, where a lot has been done in developing accurate data model to represent especially non-textual resources, via indeed using text to describe them. So in digital history and archaeology, we also have this very important relationship between objects or artifacts or cultural production, let's say, and text that sometimes documented or record these resources. So in a way, we're not that far away from that area, so we can learn from it and we can adopt some of their achievements. So, for example, in this specific project I worked on when I was based at King's College London, Henry III Find Rolls, the historians were working on Latin documents of around 1300, which were recording finds paid to the King Henry III in exchange of various concessions and favors. So obviously documents themselves, they mention occurrences of specific people name, for example, obviously very interesting for historians. But what's interesting for us here is that an occurrence of a person name implicitly obviously refers to a specific historical character, and this is where the interest of the historians was also focusing towards. So extracting specific occurrences from the text and linking them to entities, persons, with specific properties. In this case, for instance, a person, Oliver Avenel, the historians knew was the husband of a specific other person, Agnes Avenel. And potentially we might have a document where that is, of course, attested or witnessed. And this other person was the daughter of another historical character called Odo of Wonstrow. Now, depending on how we conceptualize, so in this specific project, sorry, I didn't say that we had then these two elements. We had the textual modeling, data modeling for the text itself, and then we had a conceptual model in ontology, which we could use to then specifically define the semantics of the entities that in the text were only somehow witnessed as occurrences in textual names usually. So it's important then to use this model to potentially also reason across the relationship with the entity. So for instance, in this specific case, depending on how we define the property, we could imply that Oliver Avenel, sorry, the author of Monstro was the father-in-law of Oliver Avenel. This is the kind of simple reason one could do if properties are defined properly in RDFL. Other two examples of the text, it doesn't matter if you don't understand a lot about the XML itself, the encoding itself, but we have in the first case, we have an occurrence of a person name, William de Ashford, which is actually expressed also as a toponym, so the surname is a toponym, and this was then extracted as a triple in the ontology, which relate a person to a place. And the second case, we have a text, a snippet of text which kind of attests a special kind of subject, which the historians were interested in studying, abjuration. And again, the information there was extracted to connect a specific subject within a hierarchy, a taxonomy of subjects, to a specific person and to a place. To cut the story short, the whole ontology included, of course, a set of classes that were relevant for the historians, and we used specific elements of the CIDOC CRM ontology, which I will introduce briefly, and other ontologies, making use of the concept that we needed and making explicit those concepts. Obviously, when you have this data then structured in a certain way, you could do all sorts of queries. In this case, for example, they were interested in the analysis of kinship across these documents, and that's what you could have represented if you wanted to. So, brief introduction, CIDOC CRM. So, CIDOC CRM is an international committee for documentation, stands for International Committee for Documentation of the International Council of Museums Conceptual Reference Model, very long. It's an ISO standard since 2006. It's originally developed having museums as the main audience and the main scope is documentation for museums, but it's extendable also and is extended into libraries, archives, and other kinds of institutions. It's developed by a special interest group, formed of very different kind of expertise. Is an event-centric core ontology, so let's say the perdurant, the things that happen in space and time are at the core of the model. As I said, from museum documentation is then extended into wider applications, and it can of course be combined with other ontologies. I already said it's event-centric, but I wanted to say that in addition to the class event, you have kind of main classes, a thing, place, a person, and conceptual object. I reiterate here that it's very important to look into the specific scope notes that define these concepts, because, for instance, what might be for us the notion of place in a natural sense does not correspond to the way CIDOC CRM conceptualizes place, for example. Which, of course, is very important in historical context if we're using it. For CIDOC CRM, it's very important to model each museum object within its historical context. So, as I said, the connection between objects, whether they are conceptual or not, or physical in space and time, is fundamental to their conceptualizations. I don't have the time here to go through all the various specificity of CIDOC CRM. Appellations is one of them, which we will touch upon later. So how things are named, types, so how each class can then be further refined and specified, and so on. The notion of superclass, sub and superclass is very important. I already introduced it. But it's, of course, adopted very widely. Scope notes I already mentioned, and examples. This is how the CIDOC CRM is created, and I'll give you an example just now. There are also some interesting, useful graphical representation of the standard. So here, for instance, we have the scope notes for the class E53 place. These are classes, are by the way, the naming conventions for classes, it starts with E, while for properties, you'll have the P. So you have these different parts of the standard defining the hierarchy, defining the meaning in text, defining examples, expression in first order logic, and then the properties themselves. This is an example of how you could render then the data model into RDF. I'm not going to go into details here. And this is an example instead of how CIDOC CRM then visualizes some of its model, not everything, but some of the main concepts in this way. So in this case, the oblong, the rectangular are the entities. The double arrows represent the hierarchical structure across classes. So it's a kind of is a, so E53 place is a E1 CRM entity, while the single arrow represents properties and they are directed. So for instance, a place is identified by a place appellation. I think I will now just run through this without explaining anything. We'll go back to it if any of you is interested in doing the exercise, and I will leave the floor to Charlotte so that she can introduce her specific examples, because this is indeed just for those that are interested in doing the exercise. So that's it for me. Charlotte, are you there?
Hello, I'm here. Thanks very much, Arianna. I'll just share my screen. Hang on. Okay, can everybody see the slide?
Yep.
Yep, great. Okay, following on from what Arianna has just been talking about, I'm actually going to give you an example from a project that I worked on again at King's College London when I was there. And I'm going to talk about how we went about creating an ontology for the Sharing Ancient Wisdoms project and how we used it. We thought it might be useful for you to hear about the process and about some of its successes and challenges. Briefly, this was a HERA-funded project. We worked across 3 teams, one at King's, one in Vienna, and one at Uppsala. And the project, which we abbreviate to SORS, studied the tradition of wisdom literatures, these collections of wise sayings and advice, which was transmitted through manuscripts in various languages over the course of several centuries. I'll talk further about the source material in a moment. But first I want to make a couple of points that are common to most, I think, if not all, projects that want to develop ontologies. I should say right away that the credit for developing the ontology for SORS goes very much to Anna Jordanes, who's now a lecturer in computing at the University of Kent. I can't take any personal credit for the ontology other than being involved in the discussions around the entities and the relationships that we were representing in the project. So our ontology deals very specifically with the domain of wisdom literatures. I think when I'm talking about these points that are common to most projects, I think firstly, it wasn't a simple process. It took us basically the whole of the 3 years going back and forth while we were doing the rest of the project to actually get our ontology into a state that we were happy with. I think identifying entities and their relationships, refining how we describe them, documenting this was very much an iterative process and one that required a lot of time. We were working with teams from these 3 different countries and everybody had slightly different expertise, and we found that even for terms like transcription and translation, there could be different interpretations within the team, never mind outside it. We did consult projects working with similar materials. There were at least a couple of workshops which were held to kind of make sure that we were producing something that was of interest, not only within our team and our project, but also within the wider field of people who work with wisdom literatures. So we required input in order to create the ontology from several different sources. Source focused largely on collections called nomologia from the 9th to the 12th centuries AD. They were in several different languages, but the bulk of them were in Greek and Arabic. We were trying to trace the flow of particular ideas and sayings through different languages and time periods. We had source texts which were quite varied. Some were ancient Greek philosophers, some were biblical quotations, some were other types of sources, and we also had, and we're interested in the recipient text that actually drew upon these 9th to 12th century collections of wise sayings. we had snippets or sections of text, and I'll show you a couple of examples of sayings that clearly had links with one another. But at the start of the project, we didn't have a clear sense of what types of relationships existed or how we should go about describing them, but we were interested in doing so. Often these relationships were really complex or difficult to determine. There were lots of examples in our texts where there had been different attributions, discrepancies, mistakes, bits missing, and we also found that the collections were ordered in a variety of different ways, so we wanted to be able to represent that. So for instance, with the themes, we might have one person organising the sayings about friendship, someone organising sayings about marriage, or how to conduct yourself in particular situations, and so on. So we were very interested in identifying and documenting the relationships between these snippets of texts. Here's a nice example of one of our texts. I don't speak Arabic, otherwise I would read it to you, but I can point out why we're using this one. If you see that some of the text is in black and some in red, every time you see a red section, it means "and the same man said." So essentially what this is doing is it's taking us through a selection of sayings attributed to the same person, and it's marking each one out, each saying out, by separating it with "and the same man said." Here are some examples of, that's rather nice, some examples of the kinds of snippets that we were interested in. Here we've got 4 phrases, 3 of which mention the speaker by name. I won't read them out to you, you can read them yourself, but you can see that they're attributed to different people. So at the top we have a saying attributed to Alexander, and the second one also to Alexander. It mentions Aristotle, and then we have a saying that's possibly attributed to Pythagoras and one to Aristotle at the bottom. But you can see that there are clear links between these phrases. They're the same concepts being expressed. Now, the project often didn't have any way of knowing whether there were specific sources in common, and it didn't want to make assumptions about this or about the way in which these phrases had been transmitted, unless we could be absolutely certain, which is very rare. But we did want to find a way to indicate that there are relationships that exist between these snippets of text. We decided, I think right at the beginning of the project actually, that we needed to use an ontology that would enable us to define the entities that were of interest to us and the definitions of the kinds of relationship that we were actually observing in our texts as we moved through the project. As I say, it was a very iterative process. So we started looking around to see what other relevant ontologies there were out there. We really wanted to make use of existing ontologies wherever possible, obviously for the reasons that Arianna has already pointed out. We knew that CIDOC CRM for cultural heritage data was already very widely used, so we were keen to use as many classes and properties from that as we could. But we also didn't want to try to shoehorn our data into an existing structure if it didn't fit comfortably into it. We discovered that CIDOC had many classes that we could adapt for source, linguistic object, person, language, place and group and so forth. But we also found that we needed classes for expressions, for instance, which we found in FERBER, which is the functional requirements for bibliographic records, and that was developed to model retrieval and access in online library catalogues and databases. Expressions were important to us because although they need a physical carrier, such as a manuscript in our case, they don't depend on the physical carrier. They can exist on one or more carriers simultaneously. So for instance, our nomologia, these collections of sayings, make use of expressions of particular sayings that have been selected and ordered as part of an intellectual process. So CIDOC and CIDOC and FERBA were developed independently, but they got together when they realised that a lot of what they were doing sort of overlapped or was held in common. And they produced something called FERBA-RU as a collaborative effort that included representation of bibliographic and museum information. And essentially it's formulated as an extension of CIDOC CRM. I mentioned expressions just now, so an item is an exemplar of a manifestation, which is a physical embodiment of an expression of a work, if this makes any sense. A manifestation is an embodiment of an expression, the specific form that a work takes each time it's realised, and an expression is a realisation of a work. These are all things that were relevant to us in the project. So we found that that FERBA-RU had many classes that were useful to us, and we didn't find any other ontologies that would do a better job for our purposes. You can see that we've got classes here from both CIDOC and FERBA-RU. So you can see we've got thing. I don't know how much you want to look through this. You can perhaps come back to it later if you want to, but you can see that we've used CIDOC E33, linguistic objects, and so on. Then we've got classes from FERBA-RU, expression, which I've just mentioned, expression fragment, work, individual work, complex work, and so on. And then we've added some classes of our own. We've got attributed author, for instance. This is drawn from the ontology, which you can find on the Sharing Ancient Wisdom site. There's a nice sort of AL documents version that's nicely human readable. We haven't set it out quite as nicely as CIDOC has, but hopefully it should be useful to you. So attributed author, you can see it's got a superclass drawn from CIDOC of E21 person. And actually, if you do go and have a look at the source website, there's quite a useful diagram which shows in sort of a graph form the entities and relationships that we were interested in. I might show you that later if there's time to do that. Okay, here are just a few examples, and this is really just a few that exist between some of the entities in the source project that we were interested in. So between materials, you can see we've got a very general one called it is related to, and that's how it was actually used more on the project than we really wanted, and I'll explain why later. We've got it's from same scriptorium as, is owned by, and so forth. So that relates to materials. Then with specific compilations, these collections, something can be by the same scribe as something else, or is sequentially the same as or similar to. Between linguistic objects, this was what we used for our snippets of text. We've got various types of relationships. Some are defined by length, so shorter version of, longer version of. Some are defined by how far the translation matches what appears in the original document, and you can go and have a look at the definitions for this. We'll have a look at a couple. But these are the things that we spent so long working on the definitions for. You can see that you can probably understand why a lot of people would disagree about things like close rendering, loose rendering, close translation, loose translation, and so forth. So here's is variant of. So we've got a linguistic object, a linguistically modified copy of a second linguistic object in the same language or genre and of the same length with only small variation in use or order of words. And we've given some examples of that because obviously that could be quite contentious. So we've said one or two words substituted for another or a connective inserted. And a lot of these relationships have this phrase, this need not imply that one is a direct copy of the other, nor which is the earlier. And we put that in very specifically because we didn't want to make that assertion unless we were absolutely certain that we could do so. Here's is loose rendering of, and I won't dwell on that, but you can have a look through if you like. So in each of these cases, we're describing relationships between entities within the domain of a linguistic object, and that's one of the classes which is drawn from the CIDOC CRM. Here's the linguistic object in CIDOC. And I think we should move on probably to how we actually encoded these relationships. Essentially what's going on here is we've got on the top left one one seg, it was a statement. So this is one of the snippets of intellectual interest to the project. So this is held in one document, and then on the right we've got a snippet of text from a second document. And in order to create a link between them and describe what that link is, we use the TEI relation element. And you can see that it's actually got 4 attributes. 3 of them I've highlighted, because what we were essentially doing here is we were encoding the subject and the predicate and the object, which Arianna mentioned, actually into the TEI markup itself in order to create a triple. So the active attribute there relates to the XML ID of the text on the top right. The passive relates to, this is the URI actually for the text on the top right, and then the ref is the relationship that's described in our ontology. So you can see we've used source is closed translation of here, and you can go to the ontology to look up our definition of that. So that's how we encoded our relationships essentially. The resp at the bottom, that relates to who was responsible for making the scholarly assertion of that relationship. So we wanted a way of being able to track that. It was important to the project, not least because people might actually disagree about about what they thought about the relationships. One person could say it was one particular type of relationship, another person could feel it was something else entirely, and we wanted to be able to allow people to express that and to record who was responsible. And that might be the name of one of the people who was working on the project, in this case Elvira Vekelnig, or it could be a reference to a bibliographic entry of some kind where that assertion is being made by another scholar. And so that's just a slide that sets that out clearly as to what those 4 attributes are doing. And this is all in the TEI guidelines now as well, so you can have a look there too. So essentially, we wanted to encode these relationships as part of the process of marking up the documents. This was useful in a practical sense, I guess, for us, because the people who were doing the encoding were the experts on the manuscripts, and it was useful for us to give them a sort of a simplified workflow and not have to have several different things that they had to do as part of their encoding work. So we actually encoded the relationships using, we essentially used the schema to give them a drop-down choice in Oxygen, which I'm sure you're all very familiar with. So every time they came across something that they wanted to record in a relation element, they were given a choice of all the relationships that existed in our schema, i.e. all the relationships that we'd identified and put into our ontology. And if there wasn't a relationship there that matched their needs, we'd go back to the ontology and refine it to add a new relationship and then add that into the schema so that it would appear in their list. So there was a sort of practical workflow matter which actually worked out very well for the project. And they also entered the responsibility there as well. The next step was that the RDF triples were extracted from the TEI documents, as well as the relationships we've just been describing. That also included information that was stored in the TEI header and elsewhere about the structure and the content of the documents. And there's a public Sparkle endpoint for the source RDF via a Snorkel interface, which you can go and explore if you'd like to do so on the Sharing Ancient Wisdom's website. You'll find it in Dynamic Library and then Data Exploration and Visualization. And we've also made the data available as an RDF XML file dump, so again you can explore that as well. So what did we discover during the process? Well, we found that there were several implicit assumptions that were being made about the terms that we use to describe our materials and our relationships, some of which were born of different disciplinary language and disciplinary backgrounds and different language backgrounds. Until we started writing down the definitions, we assumed that we all meant the same thing by translation, for instance, variant, version, and so on. And it was actually an incredibly useful process that forced us to be transparent and explicit about what we meant. But I suppose that we never really resolved the matter of being able to express uncertainty in a useful way. We could perhaps have used TEI attributes to do this, but what actually happened was that in some cases, the project team felt most comfortable simply stating that there was some kind of relationship that existed, so they used this is related to, but they didn't want to be any more specific than that in some cases, either because that they couldn't or because they felt uncomfortable doing so. And so that's something that I think perhaps we might revisit one day if we ever return to this. One of the things we did a lot was discussing the project with other people while it was happening, and we found that there was quite a lot of interest not only in the source materials but also in the ontology itself. We know that there are projects out there which have taken the source ontology and developed it further or are planning to develop it further, and we know also that there are those who are using parts of the ontology already in their own projects. So, for instance, there's the Biblissima project, a collection of resources for medieval and Renaissance written cultural heritage, which is looking into using the source ontology, and the project, a collaborative platform for source documents in classics, has already employed it. Here's a screenshot from their GitHub showing that they're using 4 of the relationships from source. You can see there's longer version of, shorter version of, is variant of, and verbatim of. And I guess the ultimate aims when you're creating an ontology, at least that this is how it worked for us, are to sort of reuse useful existing work. I guess the more widely used, the better. To add your own specific requirements that relate to your particular materials, and then make it available and hopefully have other projects that are reusing and extending your work. I think if we had more time on the project, we'd probably work further on scope notes and examples, and particularly on visualizations, which is something that we always intended to do as part of the project, but we sort of ran out of time and didn't spend much time on at all. So I think we're going to need to end there, and I think, sorry, I'll just skip through to the final slide. Sorry, there we go. So here's some further information, and yeah, I think I'll probably stop there, and if there are any questions, we can perhaps go to that.
Maybe before, is it okay? Can you all hear me now?
Yes.
Yep.
Yes, I was going to say that maybe before we go into the question, I could, since we skipped that part where we mentioned the relationships between a model like a data model like TI and an ontology like CRM, I could go back briefly to that if that's okay.
Yes, that would be really useful actually. Yeah.
Okay, so I'll just do that. Do you all see my screen again?
No, we're seeing you now.
No, okay. 1 second then, I have to re-share the screen. Yes. Okay. What about now?
Yeah, perfect.
Okay, so obviously this class was mainly an introduction to ontology and specifically to CIDOC CRM and applications, as you saw with Charlotte's example, in a specific context. The reason why we wanted to a little bit focus on the relationship between textual and non-textual elements was indeed that because this is something quite typical in a digital history project, where you might have some kind of textual documentations which you might be interested in studying at the level of the text itself, and then separately, let's say, for instance, a list of authority files connected to the people, historical characters, places, locations, subjects, and so on, and the kinds of more specific concepts and properties that Charlotte mentioned in her own project. So I realized that there might be some concept connected to the text encoding initiative that haven't been made explicit. So I just want to go quickly back to this idea. Let me make it full screen. So this definition of place name in CIDOC CRM. So CIDOC CRM, as I said, defines hierarchies of classes. So it tells us that E48 is a place name class, which is a subclass of place appellation, so a way to name a place. And then it says a few other things, including the fact that place names may change over time, the name of a place can change and can be reused, and so on. And if you remember, of course, the definition of place, it's quite extensive. It says that a place is, this class comprises extents in space, in particular on the surface of the Earth, in the pure sense of physics, independent from temporal phenomena and matter. And if you read further, I won't go into the details, but it's important to realize that the definition of place in CIDOC CRM is a kind of mathematical definition based on shape rather than a specific site or something you can, for instance, photograph directly. So if you look at the example, you will have the is a place, very different things are places, things like the extent of the UK in the year 2003, as well as, for instance, the position of the hallmark on the inside of my wedding ring. So very different things. So let's go down again. Now, the reason why we introduce, and specifically in the case of place name, which, as I said, is an appellation for a class place, you have this property which place name inherits from appellation, which is its superclass, and is then specified as a subproperty of identifiers, which is called P87. So, for instance, the place London is identified by the place name London. It could have other place names, of course. And the inverse of that property, so the arrow goes on one end and at the bottom goes in the other direction, that's called inverse, could be expressed by saying that London identifies the place London. Now, the reason why we introduced the text encoding initiative was to show a different kind of data model, which isn't an ontology. So in this case, TI, that's the acronym for text encoding initiative, uses as formalism, XML, even if potentially could also be expressed in other formalisms. It has a specific body organization. There is a technical council of elected members that work on the standard. So it has a parallel in its way of working with CIDOC CRM. It's got a wide scope, much wider in a way compared to CIDOC CRM, even if in the end the applications in CIDOC CRM, as we saw, is actually quite wide. And the scope is indeed to encode any kind of text in the humanities. You will have a place name concept also in the text encoding initiative. If you look at the guidelines, we have the links in the notes themselves, but it's not important now. What's important is to see that the way you can use a place name in TI is to make explicit information about the place it refers to. So you can link that place name in the text to other annotation about the place it refers to or about the name itself. So this is a very important distinction because it this concept blends two different things. So you can annotate things about the place name refers to, or you can say things about the name itself. So two different concepts blended into one. So you could have this example where you have a place name for Rochester, Rochester in the region of New York, and this is perfectly eligible in TEI. Or you could use place name to talk about, to connect to a specific URI somewhere where that place is further described. You could also use place names to talk about imaginary places. And I don't have an example here, but you could also use a place name to give further information about the, let's say, onomastic or toponomastic of a specific place, or the kind of form of the name itself. The TI guidelines has its own structure, so its own form, where you have information about the data model and so on. But what we wanted to highlight is a different ontological commitment and modeling practices in the two standards. So in CIDOC CRM, you connect place names and other entities. That's the main function of the place name itself in that structure in that graph that we saw, that it's in the slide, in one of the slides before. While in TEI, the linking to other elements representing entities is only one of the possibilities in which you can use that concept. So you can use it, as I said, also for fictitious places, which in the case of CIDOC CRM would not be expressed using that class, but something else, for instance, conceptual object or something else. And in addition, we could say that in CIDOC CRM, place name relates to documented statements about the world, so very realist kind of ontology. And in TI, on the other hand, you need the text itself to disambiguate the role of that textual structure. So this was basically to differentiate between a data model and an ontology in a specific context using these two examples. And the reason why we wanted these two examples is indeed because they represent, in a way, the combination of the study of the text in its specificity, and a data model, an ontology, explicit ontology and shareable ontology, which in the case of the source example, I think makes evident, compared to the Henry III find rules, how it can be reused and how it can be made available for other resources. Unfortunately, in the case of Henry III find rules, there was a lot of work to build this model, this data model and ontology behind it. But then in the end, that's kind of was useful for the project itself to develop its own analysis, its own indexes, but it wasn't made available to the public as, for instance, Sparkle endpoints and things like that. It was earlier on, but it's also a decision that the project made. Well, in the case of SOAS, we hope that it's much more evident how you can make use of these ontologies when they are really shared and put out there for those to use. I think that's all I had to say, but I don't know if Charlotte wanted to add something else.
No, I think that's fine. Thanks, Arianna.
And then, of course, if there are any questions or any comments, we're happy to take them.
Great, thanks.
Did you say something?
I think Gabby is experiencing a fire alarm and has therefore muted his microphone.
Oh, I see.
And
Okay.
wants us to carry on without him.
No problem. So if anybody has any other questions or comments, we're happy to take those.
Well, it would appear that there aren't further questions. Since Gabby is presumably off doing what he's supposed to do when there's a fire drill, it's probably incumbent on us to decide whether the session is over. Do I hear any objections?
We're fine unless indeed there are any comments. I think that's fine. That's great. And thanks for everybody for attending this, and thanks to those that will listen to it in other channels.
Well, yes, and thanks to you for sharing with us. It was very interesting and helpful.
Great. Thank you.
Thank you.
Right, goodbye, everyone.
Bye.
Bye-bye.